Okay folks, after a month or more of doing graphs and charts, we're going to do some good old-fashioned number work, standard form, the maths of the very small and the very big. So it's probably worth reminding yourselves of powers of 10, as that's what this is all about. If we have, for example, 10 to the power of 3, just remember that that's a 1 and 3 zeros. If we have 10 to the 6, that's a 1 and 6 zeros. If we have 10 to the power of 0, that's a 1 and no zeros. And the same applies with negative powers. If we have 10 to the minus 3, that is 3 zeros. It's just on the other side of the 1. If we have 10 to the minus 6, 6 zeros again on the other side of the 1. So what we could do is we could be asked to convert numbers which are written as a combination of powers into real numbers. And all we've got to remember here is that the power of 10 tells you how far you're going to move your decimal place. So we're going to move our decimal place 5 spaces for this first one and 4 spaces for this second one. So if we write out the digits first, then we're going to move our decimal place. So it starts between the 4 and the 3. It's going to move once, twice, 3, 4 and 5 times. The other one starts between the 3 and the 7, and we're going to move it once, twice, 3, 4 times. And then all we're going to do with those gaps that we've got now is fill them in with zeros. So we get 430,000 for the first one and 37,300 for the second. Now this general idea of writing big numbers or small numbers as something times a power of 10 is called standard form, and it's particularly standard form when the number at the start is between 1 and 10. So when this number here is between 1 and 10. We're going to look at some examples of conversions now. So let's actually change things to standard form first. Here we've got a selection of numbers, some small, some big, and we're going to try and change those. We first need to write down a number between 1 and 10 that encapsulates the digits. For that first number here, 8,400, we're going to go with 8.4, and we'll go with 1.6, 3.53, and so on. The second thing we want to do is figure out how far that decimal place had to move from 8.4 to get us to 8,400. If it made it bigger, it's a positive power. If it made it smaller, it's a negative power. So for that first one, we had to move the decimal place once, twice, 3 times to get to 8,400. So this would be 8.4 times 10 to the 3. We can do the same sort of calculation with the other numbers. So for the 16 million, we actually had to move 7 spaces from our 1.6. For the 35.3, we had to move 1 space from our 3.53. And then we have some smaller numbers on the bottom here. We do the same thing. We just count up how many spaces we had to move. So for the 0.00426, we move 3 spaces to the left. So this will be 4.26 times 10 to the minus 3. For the 0.205, we moved 1 space. So it'll be to the minus 1. And for the 9.03, it hasn't moved at all. So it'll be times 10 to the 0. So there you go, 6 numbers changed into standard form. We can go the other way around as well. So here's a series of numbers that we might want to change to real numbers. They're not quite all in standard form. For example, this is 72, it should be 7.2 if it was going to be in standard form. But we can still use the idea of looking at the power of 10 to tell us how big, how small the number is going to be. The number by the power of 10 will just say how many places to move our decimal points. So let's write down the numbers to start with. There we go. And then we're just going to need to move the decimal places by the power of 10. This first one's going to move 5 to the right. The second one's going to move 4 to the left. Let's do that now. You can see there how far we've moved our decimal places and in what direction. I think particularly notice on this 8.1 times 10 to the 0 one, we haven't had to move the decimal place at all. And now let's fill in all of the gaps with zeros. For the first two, that'll give us 470,000 and 0.000306. Do notice for the minus 4, we always have 4 zeros left in our final answer. For the next two, that'll give us 72,000, and just note that the decimal place did start after the 2, so we're not getting 7,200 here, and it'll give us 0050. I mean, we want to simplify this a little bit to 50,000, but yeah, 6 places to the right, that's what we'll get. Couple of big swings to the left here, we'll get 0.0000245 and then 0.200. Now again, you could simplify this and write it as just 0.2, and then for our last two, we'll get 8.1 because we haven't moved anything, and 31.53. Sometimes you'll get numbers which are not quite in standard form, or you might get answers which are not quite in standard form. And of course, one way to adjust them would be to write them out in full and then change them back into standard form like we've just done. But you can be a bit smarter about this. We can use what we call a little seesaw approach, which is just making one side bigger and one side smaller, and it'll work out that you get the same value. So this first one, we've got 80 times 10 to the 5. That's not in standard form because 80 isn't between 1 and 10. So we'll make 80 smaller. We'll make that 8. And because we've divided that by 10, we need to times the other side by 10, which is going to add 1 to the power to balance it out. So we'll end up with 8 times 10 to the 6. Have a go at adjusting the other 7 questions here. Unpause when you've had a go, and let's see if you're right. So the first one, you have to adjust twice. We have to decrease the 200 by 100 and increase the other side by a power of 2, so we end up with 2 times 10 to the 9. For the next one, just bear in mind, if you're making 6.4 smaller, you want to make 10 to the minus 5 bigger. It's actually going to go up to minus 4. That catches people out quite a lot. They think they have to make 64 smaller to 6.4, so they make 5 bigger to the 6, but it's not 5, it's minus 5. Alright, let's just write the rest of these in, and there we go. Do remember that a million is 6 zeros, a billion is 9 zeros, that sort of stuff might be tested as well. So having done conversions with our standard form numbers, we might want to do some calculations with them. Now, for addition and subtraction, there aren't really many shortcuts here. You've got to change the numbers to their real versions, which we've done there. You've got to then add or subtract or do whatever the sum says you've got to do with those numbers, like we've done there. And then once you've done that, you've got to convert them back to standard form. There you go, 2 excellent answers. But there is one shortcut that can be used. And that is if they have the same power of 10, you can just go straight ahead and add the numbers that are in front of you. So if we've got 7 times 10 to the 8 and 9 times 10 to the 8, we can add them both together and get 16 times 10 to the 8. Now obviously that's not quite in standard form. We'd have to do our little adjustment with it, make it 1.6 times 10 to the 9, but that's a lot quicker than writing out the numbers, adding them, and then converting them back. For the second example here, you'd probably have to adjust this one first, which would go to 30 times 10 to the minus 4. We've got to make the 3 bigger to make the minus 3 smaller. And then we can add our numbers together. So we can add our 30 and our 6.5 together, and we can take away our 5.8. That gives us 30.7 times 10 to the minus 4. Once again, you have to make an adjustment with that. It will go down to 3.07 times 10 to the minus 3. So yeah, there's a little shortcut we can use there. So with that being said, there are some really good shortcuts for multiplication and division. Let's look at 2 examples here. We've got 4 times 10 to the 3 times 5 times 10 to the 4. So there's our 2 different standard form numbers. What I'm going to do is rearrange that to have the 2 numbers next to each other and the 2 powers next to each other. Now we know 4 times 5 is 20. And we also know that if we times 10 to the 3 by 10 to the 4, we can just add the powers together. That'll give us 20 times 10 to the 7. It's not quite in standard form, so we reduce the 20 to a 2 and we increase the 10 to a 10 to the power of 8. And that's it. So the shortcut is this. Multiply the numbers, so the 4 and the 5 in this case, and then add the powers. Adjust if you need to. For division, it's similarly quite easy. I'm going to rearrange it as a sort of fraction this time. So instead of saying divide by, I'm putting them all over a fraction. I'm then going to split that fraction up to be 8 over 5 times 10 to the 4 over 10 to the 7. And I'm going to do 8 divided by 5 is 1.6. And if we do 10 to the 4 divided by 10 to the 7, that's a subtraction of powers we'll end up with to the minus 3. No adjustment necessary in that case because 1.6 is definitely between 1 and 10. So there we go, shortcuts. So here's the last sort of set of questions I'd like you to have a go. Unpause when you've tried all 6, please. Okay, so for the very first one, we should end up with this split up, which goes 15 times 10 to the 9, 1.5 times 10 to the 10 as the adjusted value. For the next one, 42 times 10 to the minus 7, that's 4.2 times 10 to the minus 6. You're decreasing 42 to go to 4.2, so you increase minus 7 up to minus 6. 17.5 times 10 to the minus 6, that's going to go down to 1.75 and up to 10 to the minus 5. And then division, same deal. We want to divide the numbers and subtract the powers this time. So 3 over 5 is 0.6, 5 minus 9 is minus 4. Again, we need to adjust this, so we're going to make 0.6 bigger, up to 6. We're going to decrease -4 down to -5, so 6 times 10 to the -5. Next one's fairly straightforward. You get 7 because you're doing 3 minus -4 on the powers there, so a minus minus is a plus, 3 plus 4 is 7. And then same one, we'll end up with 0.75 times 10 to the -5, which will adjust to 7.5 times 10 to the 6. And then there's one last type of question that they seem to like to ask on the GCSE recently, which is a question with a setup like this. We've got a large number and we need to split it into two standard form numbers. The thing to really be aware of here is that they both start with A, which means we need to split this number into two things that start with the same digits, and it feels obvious to me that that would be 1500 and 0.015. And then it's just a case of changing them to standard form and then checking, does that look like the actual form they want? Yes, I've got A times 10 to the B, so I've got 1.5 times 10 to the 3, A times 10 to the C, 1.5 times 10 to the -2. Yep, seems in order. So A is 1.5, B is 3, and C is -2. Just don't be scared of this type of question. If you see it, it's just a case of splitting the number up quite straightforwardly.